So we're in our first couple weeks of Algebra 2. How's it going so far? Yeah? Well, clap once if it's going well, and clap twice if it's going really well. Now, I guess I'm kidding about the clapping, but I'm not kidding about how it's going. It's a different kind of class, right? Yeah, it's different. It's not Algebra 1 anymore, and it's not geometry. But don't worry, you'll do well. So we're kind of looking at the way patterns can be analyzed. That's really what this unit's about. And it looks like today we're going to figure out how one change affects another change. What do you mean one change affects another change? Well, here, think about this with me for a second. If you're driving a certain speed, over maybe a pretty long distance, but if you're driving a certain speed, it's going to take a certain amount of time, right? Well, what if you drive twice as fast? What's going to happen to your time? Yeah, maybe you do kind of have an idea how one change. Now, what was the one change? We changed how fast we were going. And how does it affect another change? Yeah, it was the amount of time. Or maybe take this example that's actually our first problem here. What if you make $15 an hour and you work for 10 hours? Well, yeah, you're going to naturally earn $150, right? Not bad. But what happens if you work twice as many hours? Of course, what happens to how much money you make? Well, here, think about it. If it's twice as many hours, it's going to be 20 hours, right? You're still working for $15 an hour. And, 20 times 15, it's $300. Well, $300, that's twice as much as what I made initially, right? It's twice as much. Seems kind of basic, right? Well, yeah, it doesn't have to be hard. But what we're noticing is that there was a direct relationship. You see, there was a direct relationship between the change of hours to the change in money. And that direct relationship is that it was the same. It was the same change. Well, in algebra, we call that direct variation. And direct variation is when there's a direct relationship between the changes. Are you noticing? It's the same change. You're saying, I bet it gets harder, right? Well, I don't know if it gets harder, but there's more that we can understand about this. So whenever there's a pattern, whenever there's change, there can be an equation. Now, equations, they can be tricky, especially if you're kind of staring at a blank page and somebody's saying, well, make an equation. A lot of equations are written as y equals, so maybe that could be a place that we could start. Now, there's lots of numbers up here, but let me draw your attention to the one number that kind of stayed the same. Yeah, it was the $15 an hour, right? That stayed the same in sort of both situations. Here, let me show you. If we use 15 as our slope, as our rate, then we can finish our equation with an x where we write y equals 15x. Now, it would be helpful if we understand that the y is the money. So when we say y equals, we're really talking about how much money do we have. And then the x is the hours. What happens if I try to graph an equation like this? Uh-oh, it's time to graph. Well, don't panic. We already have some values that basically go together. Like 10 hours goes with $150. Now 10 hours, that would be like my x, and 150, that would be like my y. So 10 goes with 150. Yeah, that's just an ordered pair, that's a point. And do we realize that we have another set of sort of data, another point that goes together, 20 hours, that goes with 300. Well, I just want you to see what kind of graph we get when you graph your two data points. Just kind of by the way, if you work 0 hours, you're going to make $0. So what kind of graph do we end up with? Yeah, it's a linear graph. It's a straight line. And if you think back to Algebra 1, that's the kind of graph that you always get when you have a slope. Okay, so what's the point here? Well, the point is that you realize that when numbers have a direct relationship with each other, they appear to have a slope. They appear to end up being a straight line. Now, of course, we don't want to make a conclusion on just one problem, but here I want you to see a problem that has, it's kind of presented a little differently. It's not really a word problem, it's just a table. So what am I going to do here when I just kind of stare at this table? Well, we're trying to write an equation, and kind of like before, we said that, you know, almost all equations are going to be y equals. At least that's a good place to start. If I inspect this table, I see that the numbers are changing by, well, by the same amount. They're changing by a slope. Yeah, you don't have to overthink it. They're just changing each time by 3. Okay, and you can see that as you look at any set or any two consecutive y values. Well, that means that my equation can very simply be written as y equals 3x. What if I want to graph my table? You know, what if I want to actually plot these points? So let's make a little quick graph. We get 1, 2, 3, 4, 5, 6. We can just kind of fit those on pretty simply. And then my y value is a little bit different. I get up to 18, so how about something like 3, 6, 9, 12, 15, 18. And if I plot these points, right, I mean, I'm just plotting the points off my table. So 1, 3, and 2, 6, and 3, 9. Yeah, you can keep plotting them. Okay, yeah, what do you see is happening here? We end up with another straight line. Okay, well, that's because whenever you have direct variation, whenever you have numbers that change with a slope, you are going to get a straight line. So some of this is that we just want you to make this conclusion and start to learn this new language. Okay, so these numbers are changing in a direct way. But what we can do is we can kind of analyze them. What we really want to do here today is we want to figure out what happens to y when there's a change to x, like, you know, here when x doubles. Now, perhaps you already know what the answer is. Just a little hint, I think it's going to be the same change. I think it's going to double. But let me help you see how you can use your equation. I mean, geez, if we're going to come up with an equation, we better use it. So this is a little different. What I need is I need an x value. Now, I'm not just randomly picking x values. I mean, I'm picking kind of an x value that would be next to my list. So I picked the number 7, and I can see that I'm going to end up with a y value of 21. Now, what's important here is that you realize that I now need a double x value. So if I pick 7, now I need 14. Okay, well, 3 times 14, you can check it on your calculator, or maybe you're not surprised to see that it's 42. Why are we not surprised to see? Well, what happens to y? What happens to y when x doubles? Well, 21 goes to 42. It looks like it also doubles. And of course, we kind of knew that this was going to be the case because remember, when you have direct variation, you have the same kind of change. So what happens to y when x triples? Are we ready just to say that y also triples? Yeah, I want you to be ready to say that. That's because this is direct variation. Now remember, how did we determine that it was direct variation? Really back from the beginning, from our table. Our table had a slope, our table was a straight line, and when we were able to see those things, we can make pretty quick work of these two little questions. Now pause for a second. I just want you to reflect. What does it mean to be direct variation? What are some things that you're thinking? There's a slope, right? There's going to be a straight line. And yeah, the change that's going to occur is going to be the same. Going? Okay. Anybody hungry? Mentioned pizza and my stomach's already growling. So 4 people were going to share a large pizza pie that had 8 equal slices. Wonderful. Just stop right there for a second. What is true? If 4 people are going to be sharing this pizza, yeah, everybody's going to get 2 slices. All right, not bad. Just on a personal note, though, I probably would need to order another pizza to make sure that I can get a few more slices. But right now, everybody gets 2 slices. Until what? Until suddenly 8 people need to share the pizza. They're still sharing 1 pizza, so now 8 people are going to share the same pizza. And, oh man, only 1 slice per person. Definitely going to have to order another pizza or more. Okay, what we want to realize is how a change is affecting how one change affects another change. So what's the change? 2 slices turned into 1 slice. 2 slices turned into 1 slice. What's the change? It's half as much. Half as much. Wait a minute. I had twice as many people, and we ended up with half as much food. Now, before you say, well, wouldn't that always happen? Well, yeah, if you have what's called indirect or sometimes inverse. Actually, we can use both words interchangeably, but indirect or inverse variation. Yeah, that's going to be when one change kind of causes, I don't want to say opposite, but it sort of causes the inverse change to the other value. What would this look like with an equation? Remember, we said equations can be tricky. We understand that. A lot of equations, most equations start as y equals. Let me help you guys to see here that what we have is kind of like an original amount. We have an original amount of 8 slices of pizza. And those 8 slices are getting divided up, right? They're getting divided up by the amount of people that are going to eat them. And so we can write this as y equals 8 over x. Let's sort of label some of these things again. What was 8? Remember, it was kind of the original amount. It was kind of what I originally start with. Yeah, let's just call it starting amount. What about y? Okay, well that's that's kind of like the amount of slices that each person's going to get. How about we call it slices per person? You know, it's kind of like what I'm trying to find. And it's being divided up by the total people. All right, this one got a little trickier, didn't it? Yes, it did get a little trickier. What are we going to do here? We're going to graph some values. What values do we have to graph? Well, we've got 4 people, and those 4 people each get 2 slices of pizza. So 4 people each get 2 slices of pizza. Okay, that'll be an ordered pair. What else do we have? We have 8 people. 8 people, each getting 1 slice of pizza. Okay, remember X is the people, so we got 8 people now. And, they only get 1 piece of pizza. Okay, so 8 and 1. Now, we should be a little cautious here about our graph. What do you mean cautious? Well, I'm pretty sure when I look at this equation over here that I don't see a slope. Okay, it's not written the same way. It's not written as y equals mx. Yeah, it's a division problem. And you're going to learn a little later this year that that's actually known as a rational equation. Y equals 8 over x is a rational equation. So it's different. How about we find another data point? What if 2 people are just sitting down to share the pizza? 2 people are sitting down. That sounds a little more like it, right? 2 people, yeah, they're going to get 4 pieces or 4 slices. Oh, okay, so it gives me another data point. Oh, my points don't really seem to be in a straight line, do they? What if one person is going to eat the pizza? One person, yeah, he's going to get all 8 slices. Okay, do you see kind of what's happening with the graph? All right, let's connect the dots. If you connect the dots, it's going to be a curve. It's going to be a curve that, yes, you're going to learn more about a little later, but right now I just want you to notice kind of the shape of that curve. That is the shape that you get when you have indirect or inverse variation. Kind of interesting, isn't it? Kind of like we did with the previous problem, I can have a table of values that I can kind of analyze. Now, instead of coming up with the equation first, which we kind of mentioned, it can be a little tricky, right? I mean, I know the equation is going to be y equals, but how do I really know how to write this equation just by looking at a table of values? Well, let me suggest that if we graph the table first, maybe we can know a little bit more. So I know graphing's not everybody's favorite thing. Let me help you real quick here with this graph. How about we count by 2, 4, 6, 8, and then 10, 12, 14, 16. So we'll count by 2s on the x-axis. How about we do the same thing on the y-axis? 2, 4, 6, 8, 10, 12, 14, 16. So remember, what I'm suggesting is that I'd graphed 116. Actually, I guess it would kind of be in between here. Now I can graph 2, 8. It's all the way down here already. 4, 4. Remember, now we counted by 2, so we got to be careful. 8, 2, and then all the way out here to 16, 1, which again is going to kind of actually be down here. What do we see? Yeah, we see one of these curves, which from the previous problem is called an indirect or inverse variation. Now, what does that mean? Well, that means that I'm going to be creating a fraction. I'm going to be creating a division problem. And if you kind of use the previous example, I told you that you're always going to end up dividing by x. And the only thing I really need to do is kind of figure out what I started with. Is it as easy to say that I started with 16? Well, it is. It's my number that matches with 1 in my table. So what happens to y when x doubles? So how about we go back up here to our table, and if I need x values that double, I honestly can pick any x values. How about I start at 2? That means I'm going to definitely double to 4. Okay, so what do I see about my y values? My y value is 8, and wait a minute, does it double to 4? No, it actually gets cut in half to 4. Okay, wait, so x doubled, but y got cut in half. Should we maybe try another one? How about we go to 8? How about we go to 8? So if 8 doubles, it definitely turns into 16. So what happens to my y value? My y value is 2, and it looks like it's going to turn into 1, so it also got cut in half. Now, a little harder, but basically we're noticing that the inverse thing is happening. So x is doubling, y is cut in half. And if you don't like that word cut in half, you could just say that it gets multiplied by a half. What about quadrupling? If something quadruples, how's it changing? Yeah, it's getting multiplied by 4. Does that mean that y is going to be divided by 4? Yeah. It's basically going to get multiplied by a 4th, which is the same as dividing by 4. It's an indirect, it's an inverse variation. Now, you want to pause the video at this time, and if it's pause the video, and actually see if you can answer these questions. And then, of course, when you start to play the video again, I will help to go over those answers with you. All right, so if you're playing the video, I hope you tried something with number 1. As we suggested, maybe the easiest thing to do would be to classify. How do we know that it's indirect? Yeah, we see the form of the equation. It's in that fraction form. So it's going to be indirect, or if you like the word inverse, we said we could use both words. That would be just as good. So what happens to y if x triples? Now, you may have just been able to come up with this answer, but I just want to show you that you could have some sample numbers. How about a sample number for x? How about like the number 6? Now you say, well, where'd you get the number 6? Well, I had to pick something because what I want to do is I want to triple the number 6. So, okay, now I'm going to definitely have to use 18, and I've got my two numbers. What do I notice about my two numbers? They're not triple of each other, right? They're actually a third of each other. It's a third of each other. So we could say that the y value got cut into a third, or maybe you could say that the y value got divided by 3. Both those answers would be fine, but that helps us to perhaps be able to just give an answer to the last one here, because if x is cut in half, then the inverse thing is going to happen to my y value, right? So if x is cut in half, y is going to double. How can I be sure of that? Well, because doubling something is kind of the inverse of cutting it in half. How about making a graph? Yeah, this is kind of tricky if you don't have any numbers, but you realize that I do have some numbers. I have x equaling 6 when y equals 3. So here, x equals 6, y equals 3. How about I have x equaling 18 when y equals 1? 18, I would suppose, is probably more like out here, and x equals 1 is probably right here. Now, this is a little strange because my 2 points are kind of just all squeezed in here, but maybe I could come up with another point, right? How about if x equaled 1? If x equaled 1, then y would be 18. Okay, so that gives me another point that I can graph. Now remember, the idea here is that, you've seen a few of these graphs. Now we have some points that we can connect with one of these curved lines. How'd you do? Did you get something right on that problem, and were you able to maybe add a little bit to what you learned? Maybe you actually started number 2. Maybe that one was easier for you. I could understand it's a little easier. Again, the equation is one of these equations that has a slope, and we discussed early on that means it's going to be direct variation. You can write the word direct, you can write the word variation beside it. But remember, if you have direct variation, then you're going to directly have the same type of change. But I'd like to show you that maybe I could use my equation to, sample some numbers. So I would need an x value. Now again, you got to pick some x value. Maybe you pick the number 1. But if you're going to pick the number 1, then because x is tripling, I'm going to be forced to pick the number 3. So what do I notice that's happening to my y values? Yeah, they also are tripling. Y is also tripled. So does that mean that I can pretty comfortably say that the same thing is going to happen if x is cut in half? The same thing is going to happen to my y value? Yeah, y is also cut in half. Now, when it comes time to graph this, I know I'm going to be drawing a straight line. I mean, geez, I even know that it's going to have a slope of 6, but it would probably be helpful if I, have some actual points that I can use. So yeah, when my x value is 1, my y value is 6. So 1, and then all the way up here to 6. But when my x value was 3, probably more like out here, and then probably up here, of course, my y value is 18, and I get myself what I suspected I was going to draw, a nice straight line because it's direct variation. All right, let's finish up with these 2 extension problems. All right, so the last thing we want to do here is a little extension and just kind of pulling together everything we learned on the front. So here, let's jump in to this problem. If you're driving twice as fast, what happens to your total travel time? Does that sound kind of familiar? Yeah, it was the same question that we started the lesson with. Now, you might remember if you go twice as fast, your travel time, yeah, it's going to become less, right? It's actually literally going to be half the time. Now, if I go twice as fast and I get half the time, that sounds like an indirect relationship. But I thought an indirect relationship was going to involve a fraction. Where's the fraction in this equation? Well, that's where the extension comes in. You see, this equation, or I should say this question, is asking us about time. And this equation, well, it needs to be solved for time. How do we solve it for time? How about doing a little bit of dividing both sides by r? Now, when you do that, yeah, you end up with a fraction, which kind of matches, actually it does match, with this idea of an indirect relationship. Now, the nice thing about this equation is that it now allows us to kind of investigate a little bit some sample numbers. So one more time, just to try to help you guys get comfortable with this. Let's say that you're going 100 miles, right? Kind of a pretty long trip, but you're going 100 miles. And how fast are we going to go? Maybe it's a bike ride, so we're going like 10 miles an hour. So that's a pretty long bike ride, but you're going 100 miles at 10 miles an hour. What's your total time? Yeah, it's going to be 10 hours. Okay, well, that's nice, but I need to have twice the speed. I need twice the speed in my second scenario. So let's say you're still going 100 miles, but this time you're on a boat. Maybe a boat that's got some nice outboard motors on the back. So we're going twice as fast. We're going 20 miles an hour. What's going to happen with our total time? 100 divided by 20. Well, look, it's perfectly half as much, just like we already said in the beginning, but this kind of matches and satisfies the idea of how the one change affected the other change. Okay, perfect indirect relationship. Ready to wrap this up? Okay, I like this problem because at first glance, it doesn't look like it relates to what we did. What do we got here? We've got a square, and it's got sides, and we're talking about its perimeter. Now, typically to find the perimeter of something, you want to add up all the sides. But again, I don't remember any equations on the front of the paper dealing with adding. How about we change the way the equation looks? How about we add these four s's together, which would literally give me 4s. And yeah, that is a slope. And since that's a slope, we know that this is going to be one of those direct variations. So wait a minute, if the side doubles, am I able to say that that's directly what's going to happen to the perimeter? I hope so. But let's find out. Let's find out that it also doubles one more time with some sample data. So we just need like the length of a side. What's your favorite side length for a square? 8? Sure. How about we have a square that has a side of 8? That's going to, of course, give us a perimeter of 32. But now I need to carefully pick double that side, double 8. Yeah, I got to pick the number 16. So what's 4 times 16? Well, of course, it's 64, but what's more important is we realize that the same direct change has happened to the perimeter. That's right, the perimeter also doubled. Make it a little bit fun and a little bit of a challenge. I want to challenge you to see if you can take the 4 answers that you get for your 4 equations and add all those together. So you're going to add all your answers together to come up with one final sum. And of course, the challenge is to see if you can get that sum correct. Because if you get it correct, then I'm pretty sure you got all 4 of your answers correct.